Mr. G Math coming in live, right? Right now. 12:45, June 26th. You guys are still in school? Got beat by Jerry at tic-tac-toe. Wasn't paying attention. Here we go. So, this lesson has to do with being able to sketch rational functions. So, what to watch for when you're sketching a function. So, the domain, the vertical asymptotes, the holes, the intercepts, the end behavior, whether it's even or odd, and so on. So, we're going to start with number 1 and practice together to see if you can fill in the analysis part, and then we'll sketch on the next page. What's the domain of this function? Where do I look for the domain? The denominator. Can you factor the denominator? Yeah. And then tell me the two bad x values. So the domain is all real numbers, but x cannot equal 0 and 2. Is there a vertical asymptote? Where?
0.
At x equals 0? Where else? Is there a hole here? No. See a connection between the domain that and there? What is the end behavior? Is another way of asking, is there a horizontal asymptote? What's the degree on top and on the bottom? So what's the end behavior? 0, right? So if I asked you, what's the limit as x approaches positive or negative infinity, right, of f at x? And the answer in both directions is, so you can write the end behavior as a limit. So as you go to positive infinity or negative infinity, the answer is 0. All right, number 2. What's the domain? Look at the denominator. What can x not equal? Negative 3. Is there a vertical asymptote? At x equals negative 3, and it's an even asymptote. What's the end behavior here? So I'm going to write this as a limit. So the right end behavior, there is an end behavior, it just doesn't go to a constant. So notice the degree on top is 1 bigger, right? Yeah. So if I would simplify this, it would be 2x cubed over x squared, which is just 2x. 2x is a slanted line that rises to the right. That means the right end behavior is going where? To positive infinity. Where's the left end behavior going? To negative infinity. Try number 3. So it simplifies that the end behavior is a line where the right end goes to infinity and the left end goes to negative infinity. And I can write the end behavior as a limit, right, as it approaches infinity or negative infinity. All right, 3. Isn't that nice? They factored for you. What's the domain? X can equal positive and negative 2. H means what's the reduced form of H, not the color red. So RED there, that's just for that symbol, reduced. Is there something that divides out? So the reduced form would be x plus 4 over x plus 2. Is there a vertical asymptote? Only 1, which is that x equals negative 2. Is there a hole? Yeah. What crossed out? Make it equal to 0 and solve. What's the x value? 2. What's left over? Plug in 2 for x and solve it. Yep, 6 over. That's pretty. Leave it. And then end behavior. What's the limit here? And is it the same limit for positive and negative infinity? Yes. What's the degree on top and bottom? So it divides out. What number does it go to? Done. So both the left and right end behavior goes to 1. All right, let's talk about how we graph. Why do we analyze and graph these functions? So that's analyzing it. Talking about the domain, reducing it down, asymptotes and holes, intercepts, end behavior, and maybe some symmetry, and then graph it. So we only get better by practicing this. So turn the page. Can you graph number 4? Now, number 4 is not a rational function. Number 4 is a Polynomial. What's the domain of all polynomials? That means every x value has a y value. It's also continuous all the way through. No jumps, no breaks, right? Nothing that makes it discontinuous. So, what is the y-intercept? How do I do that? Let x be 0. 0 times anything. The y-intercept is 0. How many x-intercepts does this have? Good. So one x-intercept's at 0. What's the next factor? Is x subtract 1, positive 1, and then x plus 2, negative 2. So if I go to this graph right away, I know 0, I know positive 1, and I know negative 2. And 0 is also the y-intercept. What's the end behavior here? So to understand the end behavior, I need to know the power term. How can I find the power term when it's factored? X times x squared would be what? What does that tell me about the right end? And what does that tell me about the left end? Now, we're going to have calculus tools that teach us where the minimums and maximums are, so I don't estimate it. I know exactly where they are, but we don't have that tool yet. But we do have this tool. Does it cross or touch at each x-intercept? So at negative 2, what kind of exponent is there? So that means it does not cross over, but just touches. I don't know this maximum point here. I know there's a maximum. I don't know what it is. That's going to be a calculus tool we're going to learn. What happens at 0? Even or odd exponent? So it crosses. And then what happens at positive 1? Again, it crosses. And there's a sketch, right? These points here, right, which are very important. In calculus, I can do it without a calculator, without Desmos. So I'm going to teach you later the tools to know those points so you can sketch it more accurately without a calculator. All right, 5. What's the domain? Is there any values x can't be? Can't be 0, can't be 1, can't be 3. All from the denominator. Can you reduce this down? What does x do to x squared? Start at the beginning. X makes x squared x. What happens to the x minus 1s? Do they reduce down? Do they divide out completely? Is there 1 left on top? How about the x plus 3? There's no other x plus 3. How about x minus 3? There's no other x minus 3. So, when it says red, it means reduced. And this is what we'd write down. X minus 1, x plus 3 cubed. Denominator x times x minus 3. What are the vertical asymptotes? What is non-removable, right? What remains are the vertical asymptotes. So x equals 0. Where else? What else remained? 3. Do you notice that 1 is even and 1 is odd, looking at the denominator? Holes. Did anything remove completely? From the bottom. It doesn't have to remove from the top, from the bottom. X minus 1. So that the 0, or if you take x minus 1 equal to 0 and solve it, at what x value is there a hole? 1. If I plug 1 into what's left, can you see the answer is 0? Because 1 take away 1 is 0, and 0 times 0 divided by, the whole answer is going to be 0. Where are the x-intercepts? Look on top. Where? Why is 1 not an x-intercept? Because 1 is a whole. So not an x-intercept. Where's the only x-intercept? At negative 3. And what type is it? It's odd, right? Which means it crosses. What's the y-intercept if I plug in 0? And you would say none, because it's, when you plug in 0, it's undefined, right? At x equals 0, there's a vertical asymptote. So over the y-axis is an asymptote. What's the right and left end behavior? So if I both give you the same answer. If I multiply the top and bottom out, what's the degree on top and on the bottom? So on top is 6, and on the bottom is 5, right? So if I reduce that down, x over 6 over x over 5, What is the end behavior? And if you took the reduced to be x to the 4th over x to the 3, it would still reduce down to just what? X. So where's the right end going? Good. So the right end is going to infinity. Where's the left end as a limit going? Negative infinity. Because y equals x is just a slanted line, right? Where the right end is up and the left end is down. All right, let's put it together. So what is the graph going to look like? So at 1, 0, what am I going to draw? A hole. At negative 3, what do we have? X-intercept. What do we have over? That's all the points we have right now. The y, we have no y-intercept, right? So we have asymptotes. Where's an asymptote? At 0. Where else is there one? At 3. And do we have a horizontal one? No. I won't even worry right now about the oblique is going to be very similar to the slanted line, right? Like this. What direction are we going? Can we find points that we need? So, let's start in the middle, because I think it's easier to start in the middle. Does it cross at 1? It's a hole, but what's the exponent connected to that hole? Odd or even? Odd. And what direction is it going as we do that? So we know, in terms of this, that the asymptote at x equals thing is squared. It's even, right? Both ends? So the question is, when you plug in a number like 2 or 4, is it positive or is it negative around 3? So if I plug in 2, it's positive. If I plug in 4, it's positive, because when you square a number, it's always positive. So here and here, right around 3, both ends are going to infinity. This end's also going to infinity. That's the right end behavior, and this is the behavior at the asymptote. And then what happens at the asymptote is it crosses over the hole, and on this side, because it crosses over, is now going to be at negative infinity. What type of asymptote, vertical, is at 0? So do they match, or is one down and one above? One is below to negative infinity, the other is at positive infinity. What happens at negative 3, even or odd? So what's going to happen there? It crosses over, and then this end's going to go to negative infinity. So you have the right end and the left end behavior to positive infinity and negative infinity, and you have the behavior at each vertical asymptote, and at the hole, and at the intercept. It's like a jigsaw puzzle, right? Putting together. Jose Angel. There is. Like, remember, I kind of, you know what the oblique's going to look like? Is y equals x. So do you see that right here? Now the question is, you're thinking, why doesn't it, like this part right here, right? Like, and the answer is really simple. The only thing that it can't cross is vertical. So oblique, horizontal, that has to do with the end behavior, but it can cross over at those points. So if I take this equation, make it equal to x, in the middle, it's okay if it crosses an asymptote. Some asymptotes tell me the end behavior, and then some, like vertical asymptotes, are like would never be crossed. All right, number 6. Good question. And I'm sketching it. If I wanted to know where it crossed, I'd make the whole function equal to x and then solve it. Domain. I'm going to blow your mind. Why is the domain all real numbers? If you actually, I'm wrong. Let's not be bad about it. There's one bad number, 0. But can you have a negative number? Because when you square a negative, that's okay. And then positive. But yeah, what's the one bad answer? 0. Are there any holes here? No. There's nothing that's removable, right? Is there a vertical asymptote at x equals 0? Is there an x-intercept? So if you make it equal to 0 and solve it right, -1 is an x-intercept. Is there a y-intercept? Why? Because there's a vertical one over the y-axis. And behavior. Where does the right end behavior go to? So, this is an example where there's going to be, the power term is x over positive or negative x, meaning that there are two end behaviors. One's positive one and one is negative one. So as you go to the right, does it get positive or negative? Positive. Oops. So that's positive one. And as you go to the left, what's happening? All right. So let's put some of these on here. So those are my horizontal asymptotes. One is y equals 1, and the other is y equals -1. What's a good starting point? Can we figure out a point here? Because we also have at 0, right? What's going to happen? So, what's a starting point? Like, what would happen if I plugged in 1? Positive 1. What's the answer? So if I plug in positive 1, the answer is 2. I like that. What happens if I plug in -1? What's the answer? What would happen if I plugged in, what's another easy one to plug in? Like 2, might as well. So what would happen for 2? So if I plugged in 1, we said it's a point. At -1, the answer is 0. What would happen at 2? It'd be 3 over 2, so 1.5. Can you tell you what direction it's going? So what's happening on here? And then what's happening in between here? So we're going to talk about that too. What's the behavior going to look like here? What happens if I plug in -2? What's the answer? What's -2 plus 1? And then if I go -2 squared and take the square root of it, it's -1/2. Where's -2? -1/2. What happens when I plug in -3? So can you see the direction it's going here? What's happening in between here? Between -1 and 0? What happens if I plug in -1/2? What's -1/2 plus 1? -1/2 plus 1 is +1/2. If you square it, right, and square root it, it's positive. And what's 1/2 divided by 1/2? That'd be 1. So at -1/2, the answer is what? 1. Keep going. What happens when you get to like -1/4? So at -1/4, you have +3/4. And then on the bottom, you would have positive a quarter. The 4's divide out and you get 3. What's happening on the right side? Where is it getting closer and closer to? So as I put in numbers closer to 0, what's negative 1 over 100 or negative 1 over a billion? This answer up here is getting closer to infinity, where you have the left and right end behavior. Funky looking, isn't it? Okay. Now you get to practice.